Welcome to NIOP Chemistry. Good morning students, how are you? I hope you are all fine at home. And please watch this program till end of this video. Today our topic is about the matter that is present around us. How this matter made up of? What things makes up this matter? Different kinds of materials, different kinds of substances are present around us. In our day-to-day life, we come across to see a number of materials and substances. What these materials are made up of? See, including plants, animals, and rocks, water, and ourselves also. Whatever the thing, maybe it is living thing or non-living thing, no matter, each and everything that is present in this universe, not on the earth, whole universe consisting of different kinds of materials. All these materials and substances considered to be matter, and this matter broadly classified into two: living matter and non-living matter. Living matter deals with plants and animals, and anyhow this living matter topic you will study under biological science. Come to non-living materials. Non-living materials are again classified into pure substances and impure substances. How can we understand whether the substance is pure or impure? Pure substances have definite set of properties, whereas impure substances have no definite set of properties. The properties of some substances may vary by changing some factors like pressure or temperature, or if we add any other materials into the substance, its composition may change, or some of its physical properties or even chemical properties also show some changes. Okay, come to these pure substances. These pure substances further classified into two: elements and compounds. Today we are going to discuss in detail account of these elements and compounds. What are actually elements? Elements are the basic raw materials that makes up this entire universe. No doubt of it, whatever the material that is present on this earth, in this universe, definitely it must be composed of different combinations of various basic raw materials. Those basic raw materials, we call them as elements. According to modern chemistry, the definition was given for an element like this: element is the simplest form of a substance which cannot be further divided into two or more substances by means of any chemical process or physical process. That means if we take a particular substance, we cannot divide it into further any simpler substances. I am going to put a simple example in front of you. Take a bar of gold, cut it into pieces. If you cut a bar of gold Will you get any silver piece or will you get any iron piece? No. Then again you make it into, divide into as possible pieces. Take one of the pieces. It will give the properties of the parent substance gold. Okay, now apply another process. Take the piece of the substance and make it into a fine powder that we can make. In that fine powdered gold substance, take one single particle. Even that single particle is able to show the properties of gold. That means we applied here physical process. There is no change in the composition of that substance, and what properties the substance has with its parental state, the same properties the smallest particle also shown. Even after the substance react with another substance also, it won't lose its identity. It still remain in its identity. For example, hydrogen reacts with oxygen, forms H2O. Hydrogen, oxygen, both are combined chemically and they formed H2O. That means here we have taken hydrogen. Hydrogen is present on the product side, and oxygen we have taken. Oxygen also present on the product side. So from this simple example, what materials we have taken, the same materials are seen in the form of product. So they are maintaining their identity. They are not losing their identity throughout the chemical process also. So from these two simple examples, it is clear that element is a simpler substance which cannot be divided further into two or more simpler substances by means of physical or chemical process. Okay, here under element we can study number of elements. Nowadays it's reached 119 elements, and these 119 elements further classified into four groups: metals, non-metals, metalloids, noble gases. Depend upon the characteristic properties of the elements. Some elements were grouped. So here metals, maximum the elements are showing properties nearly same. So those all elements were put under a class that is given a name metals. Likewise non-metals and metalloids and noble gases also. These are the four classes of elements we have with us. And here these basic elements are combining with one another. Why they are combining? Yes, here elements are reactive, they are unstable, so they are combining and they are forming a substance called compound. Here elements are classified into four groups: metals, non-metals, metalloids and noble gases. Here for metals, some examples I wrote here. Gold, silver, copper are the well-known elements, because in jewelry we'll see these elements: gold ornaments or silver ornaments, and copper is mixed with this gold and silver. Even individually copper also they use for making some ornamental pieces. And additionally here aluminium, iron, what metals we are using in our day-to-day life maximum for making the body parts of vehicles or machines or any other purposes, building materials, mainly of iron. They are using iron, the element maximum. In its pure state not, but they are mixing this iron with some other elements, carbon, some ingredient they are mixing, so that make it strong and stiff, and it won't get rust also. That means it cannot react with atmospheric air or whatever the gaseous materials present in the air. The next aluminium. After iron, people are using maximum this aluminium only. So nowadays people are using this aluminium mixing with some another metals, making an alloys which are light in weight. They are using it for making some window frames or door frames or some air buses, airplanes, or whatever it may be, the vehicle that is flying into the sky. Its body parts are made of the alloys made using the main metal aluminium. So one by one we can go likewise. Okay, the next one is sodium, highly reactive metal. Actually I did not write here. Sodium, potassium. So likewise some more metals are there. So why I mentioned here sodium? Sodium is one of the most important, along with the potassium also, which are playing vital role for carrying messages throughout our body. So sodium ion and potassium ion are playing. So many metals, they are playing vital role in our body. There is no doubt of it. And here sodium react with a non-metal chlorine and it forms sodium chloride. Table salt, what we are using at our home, using it for preserving some pickles, or we add it into some curries which gives flavor and taste for that curries. That is the importance of sodium when it combines with chlorine. The next one, come to another group in these elements, non-metals, hydrogen, oxygen, nitrogen, chlorine. Many elements are there. And these non-metals, hydrogen, when it combined with the oxygen, it forms hydrogen monoxide, water. I already explained this example in previous video. I have already explained about the reaction between hydrogen and oxygen. The main reaction every time taking place in between metals and non-metals, no doubt of it. Metals always forming positive ions, whereas non-metals forms negative ions. So between these positive and negative ions, reaction takes place. So this point you need to keep in your mind. It will help you to understand further topics. The next one, metalloids. Actually metalloids are few in elements. So these elements, I wrote only 4 elements as an examples here, and these metalloids are placed in periodic table, placed in between metals and non-metals. Why metalloids are placed in between metals and non-metals means these metalloids have some properties of metals and some properties of non-metals. By this reason metalloids were placed in between metals and non-metals. Even you can give a definition for these metalloids. Metalloids are the group of elements which shows some properties like metals and some properties like non-metals. And examples for metalloids elements I wrote here. You can see that. The next one, noble gases. Noble gases, these are group of elements which do not combine with any other element. Not only among themselves, they won't react with any other element from other groups. That means they are individual. They never have any reaction with any other substance. They exist in monoatomic form. Those are called noble gases or inert gases. Inert. Why the name inert is given for these gases? Inertness. They are unreactive. They are not showing their interest to combine with any other element. By this reason, the name given as inert gases. Such elements are here, 6 are there: helium, neon, argon, krypton, xenon and radon. This is also very important and will help you to understand further topics also. Now the topic is about compound. What is compound? How these compounds are made up of? Okay, see here, definition for a compound. For giving this definition, I am using only the properties of the particular substance. Their characteristic properties only I am using. Okay, see here. Compound is a pure substance, and these compounds are formed from the combination of 2 or more elements, and they are combining chemically, and they are combining in a definite proportion. Definite ratio is existing between the elements that are combining chemically. We can take the definite ratio by their volume, or we can take the definite ratio by their mass also. Okay, in detail account, let us see the definition of compound substance. Compounds are pure substances formed by the chemical combination of 2 or more elements in a definite proportion or definite ratio by their volume or by their mass. Okay, let us see how can we check whether they have definite ratio by their volume and by their mass. Using these 2 properties, we can I've taken here an example: water. Water is formed by the chemical combination of hydrogen and oxygen in a definite proportion. What is that definite ratio that existed between this hydrogen and oxygen? See here, by mass. By mass. Here hydrogen 2, the mass of hydrogen 2 and the mass of oxygen is 16. Don't think that hydrogen, I am not saying the mass of hydrogen atom is 2. Here considering the molecule, one molecule of water, this is one molecule. In this one molecule, 2 hydrogen atoms are there. Each hydrogen atom mass is 1. Together 2 hydrogen atoms, 2 multiplying 1 is equal to 2. 2 is the mass of hydrogen present in one molecule of water. And one oxygen atom mass is 16. As it is here, I have taken here the mass of oxygen. Now take the simplest ratio between this hydrogen and oxygen masses. So 1 is 8. This is the definite proportion. How can we understand that there existed a definite proportion in between hydrogen and oxygen in water? Means you just collect the samples of water from different sources. Pure water, I am not asking you to collect impure water. Impure water means it may contain of different dissolved salts or gases. That not. Pure substance, water alone, that you extract from living sources, maybe animals or plants, and even you can collect it from atmosphere and from some different source of water. Separate the pure state of water and check the ratios of hydrogen and oxygen present in that water. You will get the simplest ratio and the definite ratio 1:8. Likewise, here by volume, again taking the molecule, one molecule of water contains 2 hydrogen atoms, so the volume of hydrogen is equal to 2, and here 1 atom of oxygen is present, so 1 volume. So how can we identify this definite ratio from this single molecule of water, or if we take any other substance? Balanced chemical equation gives us full account of it. That means in detail account or maximum information we'll get from that chemical equation. So in that balanced chemical equation, we'll get the volumes of different substances. So here in this 1 molecule of water, 2 hydrogen atoms and 1 oxygen atom is present. So let me write that balanced chemical equation so that you will understand that. Here hydrogen reacts with oxygen to form water, H2O. It is not balanced. Now here I am taking 2 molecules of hydrogen and 1 molecule of oxygen, then it forms 2 molecules of water. This is now balanced. So here 2 volumes of hydrogen on treating with here no values there means we'll take 1. So 2 volumes of hydrogen on reacting with 1 volume of oxygen, it's forming 2 molecules of water. So likewise we'll take the ratio between the 2 constituents that forms a compound from balanced chemical equation. Here some similarities and dissimilarities between elements and compounds. Here only one dissimilarity that noticed in broad. So here elements are made up of only one kind of atom, whereas compounds made up of only one kind of molecule. And here further you need to know about molecule. Molecule is not a single atom, it is a combination of 2 or more atoms. Different atoms in a definite ratio they are combining. So here element means throughout the substance only one kind of atoms will see, but in this compound that is depend upon the number of constituent elements that combine to form a compound. If 3 elements are combining, then 3 types of atoms will see in this compound substance. But among these number of element atoms, if you are taking 3 different elements or 4 different elements, between 3 kinds or 4 kinds of atoms there exists a ratio, definite ratio. So finally we conclude that only one dissimilarity that was noticed between elements and compounds. The next remaining all are similarities. Elements are homogeneous, they are uniform. Compounds also homogeneous. And here elements have definite set of properties. Here compounds also have definite set of properties. So some more properties also we can study in broad views.